Hey, my name's Josh, and in this video, I'll be performing Radix sort on these 7 TDSB student numbers right here. Now, as you guys probably know, the time complexity for Radix sort is O d times n plus b, where d is the number of digits, n is the number of entries, and b is the base that we're using. So in this case, we have 9 digits in every TDSB student number. We have 7 entries in total, and we're using base 10, which works out to about 153 operations in total to sort all of these numbers. So every single iteration, or a pass, I'll be sorting by exactly one of these digits, starting from the very last one as our key. Now, since 153 operations is quite a lot, I'll only be showing the first 2 iterations in full detail, and the rest I'll just speed through it. Now we're going to fill in this count array. The count array represents how many numbers there are that have that digit as their key. So as you can see, the ones I've highlighted right now, those are the units digits because this is the first iteration. For the 0th index, because the key right now is 6, we add 1 to the 6th box. Then for the first element, the units digit is 2. The second one's 9. The third one's 7. And there's 2 more 7s. And then there's a 2. Now, as you can see, I've converted those tallies into actual numbers. But now, I should actually explain what the count array really represents. So the reason why we need a count array is so that for the final resulting array, we know exactly how many numbers there are that have a digit that is less than or equal to I, for all I from 0 to 9. Now, that might sound a bit vague, so let me give some examples. Firstly, for the digit 2, there are exactly 2 numbers that have a units digit of less than or equal to 2, which is pretty obvious, right? But for 7, let's say, there are 2 2s, 1 6, and 3 7s, all of which are less than or equal to 7, which means in total there are 6 numbers that have a units digit of less than or equal to 7. That actually gives us a definition for the prefix sum array. The ith index of the prefix sum array is the sum of all numbers in the count array from 0 to the ith index. So for 7, it would be the sum of everything from here to here. Thankfully, there is actually a way to calculate the prefix sum array in linear time. Let's say we knew the prefix sum array for 6. If we wanted to calculate the prefix sum array for 7, all we need to do is add 3 to the previous one, because the previous one represented the prefix sum from 0 all the way to 6. So when we add 7 to that, it now becomes the prefix sum from 0 to 7. Now let's go ahead and do that on this prefix sum array. Obviously, the first index will be the same as the count array because nothing else is added to it. But for the first spot, it would be equal to 0 plus 0, so 0. Then for the second spot, it's 2 plus 0, so 2. And for the next 3, they're all 2s because nothing's really being added to them. And then for the sixth spot, you have 1 plus 2, so 3. And then 6. And 6 again because nothing's being added to it. And finally 7. And actually that checks out because the very last number should have everything included in it. And we started with 7 numbers, and so the prefix sum array for 9 should be equal to 7. That makes sense. After calculating the prefix sum array, I have rewritten it now for 2 reasons. Firstly, remember what I said about how the prefix sum array represents how many numbers have a key that is less than or equal to that digit? The point of doing that is to actually allocate spaces in the final array so that all the numbers have exactly enough spots to fit in. You can think about it as if all these numbers were actually booking spots in a restaurant. This count array would be the RSVP letters, and the prefix sum array would be the restaurant's agenda, so that they know how many spots they need. And that's actually why I subtracted 1 from all of these numbers in the prefix sum array. It's so that they could represent the indices in the final array. The second reason why I rewrote the prefix sum array is because my little brother's handwriting is atrocious. Now we will transfer the initial array into the final array, and we'll do this by looping backwards. So starting from the last element, the key, so the bucket that it belongs to, is 2. And the prefix sum array of 2 points at position 1. So we're going to take that and put it in position 1. However, we also need to make sure that we subtract 1 from the prefix sum array. The reason why is because, well, imagine if we found another element that has a key of 2, right? If this said 1, then we would have to put it in the same spot that we put the other one, which would crush that one. So instead, what we do is we subtract 1 from it to make sure that the next time we find a 2, it goes over here. Now, the 5th element has a key of 7, so we look in the 7th box, we put that into position 5, and we subtract 1 from it. The 4th element also has a key of 7, but now it says 4, so we put that there and subtract 1 from it. The third element also has a key of 7. Now it says 3, we put it in here and subtract 1 from the 7. Then the second element says 9, so we take that and put it here, it says position 6, so we put it in position 6 and subtract 1 from it. And the first element says 2, so we checked index 2, it's at 0, and we put it there. And finally, the 0th index belongs to bucket 6. Bucket 6 points to 2, so we put it there and subtract 1 from it. And finally, we're done. We have successfully transferred the initial array into the final array, and as you can see, the units digit is actually increasing throughout. So we've successfully sorted it by the units digit. Now we've transferred over the final array from the first iteration into the initial array for the second iteration. So just like we did before, we will loop through the initial array and make tallies for the count array. So from the first element, well, right now, because the key that we're looking at is the tens digit, this one actually adds 1 to the tally for index 3 of the count array. The first element, this one adds to the 6. This one adds to the 7. Then the 8. Then the 4. Then the 3. And the 1. After converting those tallies into actual numbers, we will now fill out the prefix sum array. So the 0th index stays the same as the count array because nothing else is being added to it, but the first index becomes 1, and then 1 again. Then we add 2 to the 1, so 3, then 4, then 4 again, then 5, 6, 7, and lastly 7 again. Just like before, I subtracted 1 from every element in the prefix sum array, and now I will copy the initial array into the final array, looping backwards from the last element. So element 6 belongs to bucket 1, which points to position 0, and we put that in position 0, and subtract 1 from it. Then the element in position 5 belongs to bucket 3, and that points to position 2. So we put that there, and subtract 1 from it. 3. Position 4 belongs to bucket 4, which points to position 3, so we put that here. And subtract 1 from bucket 4. Then element in position 3 belongs to bucket 8. So it points to position 6. We copy that over to position 6 and then subtract 1 from 8. Then element in index 2 belongs to bucket 7, which points to position 5. So we copy it here and subtract 1 from 7. Then the first element, index 1, belongs to bucket 6, which points to position 4. So we put that in position 4 and subtract 1 from it. And the last one belongs to bucket 3. So that points to position 1. So we put that there and subtract 1 from it. By the end of the second iteration, if we look over the final array, we notice that the last 2 digits are actually all sorted. So this one's 19, 32, 37, 47, 62, 76, and 87. So that means we've sorted all the numbers by their last 2 digits. And I'm not going to show the rest of the iterations, but I will show you the result from each one. And at each step, notice that the last n numbers, if that entire number was just shortened to those last suffix, then it's actually all sorted in order. If we continue, and by the end of the 9th iteration, all the numbers are sorted by 9 digits. Now this is the end of the 3rd iteration. 19, 137, 162, 232, 347, 576, and 687. This is the end of iteration 4. This is the end of iteration 5. This is the end of iteration 6. This is the end of iteration 7. This is the end of the 8th iteration, although you might notice that all the TDSB student numbers start with a 3, 4 anyways, so the last 2 iterations doesn't really change the order, but I'll show them anyways. And finally, this is the end of the 9th iteration. All the student numbers are sorted.